So today I am going to explain planetary motion, Kepler's problem. So the first thing that I am going to explain to you is uh, the introduction of Johannes Kepler, the one who formulated the three laws of planetary motion. So who is Johannes Kepler? Johannes Kepler was born into a poor family in Germany. He attended university at Tübingen and studied for a theological career. He then learned the Copernican system and soon converted to the heliocentric hypothesis. Through his analysis of the motion of the planets, he developed a series of principles known as the Kepler's three laws of planetary motion. Kepler's three laws of planetary motion can be stated as follows. First, all planets move about the Sun in elliptical orbits, having the Sun as one of the foci. Second, a radius vector joining any planet to the Sun sweeps out equal areas in equal lengths of time. And the last but not least, the squares of the sidereal periods of revolution of the planets are directly proportional to the cubes of their mean distances from the Sun. Knowledge of these laws, especially the second, the law of areas, proved crucial to Sir Isaac Newton's in 1684. So, the first law of planetary motion states that the planets move around the Sun in elliptical orbits. An ellipse is a shape that resembles a flattened circle. How much the circle is flattened is expressed by its eccentricity. The eccentricity is number between 0 and 1. The second law of planetary motion by Kepler states that a planet moves in its ellipse so that the line between it and the Sun, placed at a focus, sweeps out equal areas in equal times, sometimes referred to as law of equal areas. This law describes the speed at which any given planet will move while orbiting the Sun. This also explains that the speed at which any planet moves through space is constantly changing. The last but not least, the third law of planetary motion implies that the period for a planet to orbit the Sun increases rapidly with the radius of its orbit. The squares of the orbit periods of the planets are directly proportional to the cubes of the semi-major axis of their orbits. The ratio of the squares of the periods of any two planets revolving around the Sun is equal to the ratio of the cubes of their mean distances from the Sun. Or the path of a particle moving under the influence of a central force whose magnitude is inversely proportional to the square of the distance between the particle and the force center can be obtained by this equation. It's theta is equals to the integral of 8 over r square dr divided by the square root of 2 mu times e plus k over r minus l square over 2 mu r square plus the constant. Integral can be evaluated if the variable is changed to u is equals to l over r. If we define the origin of theta so that the minimum value of r is at theta is equals to 0, we will find that cosine theta is equals to L square over mu k times 1 over r minus 1 over square root of 1 plus 2 times e L square over mu k s square. Instance, alpha is equals to L square over mu k. Meanwhile, epsilon is equals to square root of 1 plus 2e L square over mu k s square. This can be thus written as alpha over r is equals to 1 plus e cosine theta. That's it. So the mean distance between the Earth and the Sun is 1.5 times 10 to the power of 11 meter. The mean distance between the Sun and Mars is 2.87 times 10 to the power of 11 meter. What is the period of Mars around the Sun in Earth days? So this is the thing that we are going to see. So say for example, ito yung Sun, ito yung Earth, and ito yung Mars. So the distance between the sun and the earth is equals to 1.5 times 10 times 10 to the power of 11. Meanwhile, the distance of the sun to the Mars is equals to 2.87 times 10 to the power of 11. So it means to say, ang ating R1 is equals to 1.5 times 10 to the power of 11. And our R2 is equals to 2.87 times 10 to the power of 11. So as the, based on the problem, the question is, what is the period of Mars around the sun in Earth days? So it means to say we are going to look for the t squared. So here is the equation for Kepler's third law of motion. So t2 square at saka t1 square is equals to r2 cube over r1 cube. So ganito yung gagawin natin. You just have to plug in the numbers and then cross multiply and then ito yung makuha natin, yung t squared 2 will be equals to t1 square r2 cube over r1 cube, which is equals to 365 days. 365 days yung period ng pag-orbit ng Earth sa Sun. So 365 days yung t1, and then r square is equals to 2.87 times 10 to the power of 11 over r1, which is the 1.5 times 10 to the power of 11. Then you have to count on that. Okay. So counting it, so the answer will be 47,183.1. Since t squared is squared, kailangan natin tanggalin yung square, kaya lalagyan din natin ng square yung sa other side. So ang mangyayari, yung t2 natin is 687 days. So let's go to the next question. Next question is, it takes Venus 2 to 5 days to orbit the sun. If the Earth-Sun distance is 1.5 times 10 to the 11 m, what is the mean distance between Venus and the Sun? So this is very easy. So ito yung illustration. Say for example, this is the Sun, this is the Venus, and this is the Earth. So if the distance between the Sun and Earth is 1.5 times 10 to the power of 11, what is the distance between Venus and the Sun if it orbits around the Sun on around 2 to 5 days? Here's the answer. So same process, yung formula, same process. So say for example, cross multiply after plotting the values, same. Okay, so you just have to same multiply. So 2 to 5 days, yun yung days ng pag-rotate ng Venus sa Sun. And then 365 days yung sa Earth naman. So r square, so cross multiply, ang mangyayari is ganito, 365 square r2 cube divided by 365 square over 3, which is equals to r2 cube is equals to 1.28 times 10 to the 33. So it means to say the distance between Venus and the Sun is equals to 1.28 times 10 to the 33. So lalagyan na naman yun, since this is our cube, we have to kailangan tanggalin yung r cube. So divided by 1/3, and so it will be cancelled at mga matitira lang is r squared, tapos ito lalagyan ng r cube. So ang magiging answer is 1.08 times 10 to the 11 m. This is the equal distance between the Venus and the Sun. That's all. Thank you.